At UBC Steel Bridge, we design bridges that give back. The Petite Kodiak River has long provided sustenance, transportation, and community connection to residents of the area now known as Moncton, an economic hub of New Brunswick and a vibrant cultural hub of L'Acadie today. A new bridge crossing presents the opportunity to strengthen sustainable active transportation connections for the growing hub city. Through our 1-to-10 scale model bridge design, together we can sustainably fill a known gap in Moncton's active transportation network while preserving the ecological and cultural value of the Petite Kodiak River.
Working on the traditional, ancestral, and unceded territories of the Musqueam people here at UBC campus has deepened our understanding of stewardship to the land, shaping our commitment to sustainable design.
Sustainable design means doing more with less. Our bridge design does more with less through 3 key objectives: structural efficiency, lean fabrication, and economical construction. Let's explore together how these key objectives are reflected in our design.
Weighing 225 pounds,
our model bridge is anticipated to have an average aggregate deflection of 0.25 inches under a 2,500 pound load. Our under-truss bridge design evolves across its length to address local site constraints. The mid-span features an X-truss system with optimal stiffness for safe,
navigable clearance over the Petite Kodiak River.
Arch-shaped struts provide a robust load path from the X-truss to the piers at the east and west ends of the main span. 2-dimensional Warren-like members make up the piers and cantilevered portion at the east end where robust moment and shear resistance is needed for safety and durability.
Our design process began with topology optimization using Inspire to generate concepts which place material and strength where they're most needed. Each frame concept and design iteration was vetted through linear analysis using S-frame. The final frame structure proves robust even when accounting for buckling through second-order analysis.
Additionally, we developed a Python-based joint optimization tool that uses numerical methods such as SLSQP to design within our structural and fabrication constraints. For a given joint type, structural designers input expected conditions such as axial force or bolt diameter, and the tool outputs optimized joint parameters. Compared to traditional spreadsheet iteration, this approach converges on solutions more quickly and accurately, allowing us to explore a wide range of design scenarios.
Doing more with less doesn't stop at structural efficiency. Keeping our bridge as modular as possible is key to lean fabrication and construction. Our modular design approach breaks down silos and is one of many ways we minimize material waste and dimensional error. A reduced number of unique parts and assemblies make both fabrication and construction easier and leaner. In our design, 46 total members are simplified to 16 unique assemblies. 94 total member connections are simplified to only 5 member connection types.
UBC Steel Bridge also brings experience collaborating with local industry partners for a lean fabrication process that delivers as designed. ASC and CIC compliant fabrication documents drafted in-house are our key to precise technical communication between our different partners. All materials used to fabricate our bridge model are sustainably sourced through local Canadian suppliers. Member parts were cut in-house and are then assembled and welded in partnership with Mixed Steel. Assembly jigs are designed and fabricated to ensure our members are welded with precision.
To reduce construction costs and environmental impacts, our lean construction sequence uses modular assembly where possible. This simplifies staging and assembly for faster and safer installation. One builder creates assemblies at the staging yard and hands them off to barges to construct the 2 spans of the bridge. The cantilever and laterals are connected in the final stage. The modular design of the X-truss midspan results in a faster construction time and minimizes disruptions to the navigation channel. All in all, our construction process takes approximately 10 minutes using 1 builder and 3 barges.
Over the past year, UBC Steel Bridge has incorporated our sustainable design thinking into every process from start to finish.
This year didn't come without struggle. Rethinking fabrication methods, refining design constraints, and pushing through setbacks.
Given what we've learned, we are prepared to full-scale this model and adapt to future challenges.
Together, we can deliver a bridge that not only meets requirements, but elevates the standard for sustainable bridge design.